Hi, welcome to National 5 Practice Paper B. This is a Paper 1 practice paper, so no calculator allowed. Right, let's make a start. Number 1. Evaluate. It's a simple number question. It's related to BODMAS. Remember BODMAS? Any brackets you see, do them first. Any divisions and multiplications should be done first. After that, and any adds or subtracts at the end. So we've got a subtraction and a multiplication in this question. So we're actually going to do the multiplication part first. Okay, so the 2.1 times 3. 2.1 times 3. I know you could probably do it in your head. 3 1s are 3, 3 2s are 6. 6.3. So what we really have is 7.18 take away 6.3. Try not to do this in your head. I mean, I know some of you probably could. 7.13 take away the 6.3, or 7.18 rather. Not 7.13. 7.18 take away 6.3. You'll notice I've got the numbers in line, the decimal point in line. If you want, you can put a 0 here. 8 take away 0. 8. 1 take 3 you can't do, so we're going to cross here. And we're stealing 1 from it. 11 take 3 is 8. Put your point in. 6 take 6, the answer is 0.88. Right, number 2. Fraction question. It's a fraction division. We've got 1 and 1/8. I would convert the 1 and 1/8 first. I wouldn't leave it like that. That's always what I would do. Remember, you're turning into eighths. 8 times 1 is 8. Add on the 1 at the top is 9. So it's 9/8. You can do that part in your head. Okay, you don't need to show working for that. So basically what the question is 9/8 divided by 3/4. And to do that, the method is 9/8. What do we do for division? We flip the second one upside down and we change it into a multiplication. Okay, you can multiply straight across the top now if you want, or if there's anything you can simplify diagonally, top and bottom, then that's fine. I'll do a wee bit of simplifying. 4 and 8, divide them both by 4. 2 and 1. The 9 and the 3, I can do a wee bit of simplifying here as well. Divide the top and bottom, 9 and 3 by 3. A 1 and a 3. 3 times 1 is 3, along the bottom 2 times 1 is 2. So 3 over 2, or you can write 1.5, it doesn't actually matter which way you write it. Okay? Number 3, let's see, solve the inequality. So first thing I'll do is I'll get rid of the brackets. Multiplying out, 2 times x, 2x, 2 times 1 is 2. Okay, and then I'll get all my x's onto the one side of the, I was going to say the equal sign, one side of the inequality symbol. It doesn't matter which side you put your x's on. I'll put them on the left hand side because that's the way most of you would probably do it. So I'm going to keep the negative x on this side. I'm going to move the 5 across. Okay, and I'm bringing the 2x's across to here. Now if the 2x moves across, it becomes a take away 2x. Inequality symbol's the same. It's a positive 2 that's still on that side. I'm not moving it. It's still a positive 2. However, the 5 is moving across from the left over to the right, so it becomes a take away 5. Okay? Altogether, we have negative 3x's, because you've got negative 1 and another 2 more, so it's negative 3x's greater than negative 3. Now, how do we find x? Well, to find x, we divide the negative 3. Where does this go? Underneath. But what do we have to remember? When we're doing that, when we divide by a negative number, if you divide by a, what was I going to write there? If you divide by a negative, you need to flip the symbol. Flip or reverse the symbol. So the answer is x is less than. 3 divided by 3 is 1. Negative divided by negative is a positive. Positive 1. X is less than 1. Number 4. Find f of negative 3. This is a simple substitution. To find f of negative 3, you simply replace x by negative 3. So it's negative 3 that's to be squared. Add on 5 times negative 3. Negative 3 squared. Remember non-calculator, 3 3s are 9. Plus 5 times negative 3 is negative 15. And remember also, 9 plus negative 15 is 9 take away 15. All those steps of working don't really have to be shown. 9 take 15 is negative 6. Okay? Yep, that's that one done. Number 5. Vector u has the components and vector v has these components. Calculate, remember the two wee lines down the side means the magnitude. Okay, that's what they're looking for, the length of the vector. What's the magnitude? First of all, I'm going to work out 4u, which means multiply all of these by 4. And then I'm going to take away 2 of vector v's. Okay, so 4 of this, times them all by 4. That's me multiplied them all by 4. And I'm going to times all these ones by 2. And then I'm going to get the answer. 12 take 4 is 8. Negative 8 take away negative 8, 0. Negative 4 take away 2 is negative 6. So that's the magnitude, that's the vector. Now we're going to work out the magnitude of the vector. And remember, the magnitude is, what do we do with each of the components? We square them all, add them all up, and take the square root. Square them all, 64, 0 and 36, and they'll all be positive because we're squaring them all. Really what we've got is the square root of 100, and the square root of 100 is 10. Okay. Number 6, factorise. Factorise. Remember, you've got your 3 different types of factorising. Common factor. Is there a common factor here? Always look for that first. It's definitely not a common factor. Another type of factorising is your trinomial, your quadratic trinomial. You've got your 3 terms. That's definitely not that. So this is another type of factorising. It's the difference of 2 squares. You've got p that's squared, and you've also got a squared term here. Okay, p times p is p squared. Now what do you put at the end of the bracket? It's basically what do you square to get 4q squared. What number squared gives you 4? 2. 2q times 2q gives you 4q squared. And to complete it, one's a plus and one's a minus. Okay? Part B, hence. It says hence simplify. That now means now use your answer that you've just got. You'll notice the top line of this fraction is part A. So I'm just going to write p plus 2q, p take away 2q. Okay, because we've already factorised that bit. Right, the bottom of the fraction. We're going to factorise this as well. To simplify algebraic fractions, you factorise. You don't start scoring out p's and q's top and bottom. You factorise. So, how do you factorise the bottom part? 3p plus 6q. We've talked about factorising. There is a common factor. The common factor is 3. If you take out 3 as a common factor, you need the letter p for the 3p, plus, what do you multiply here in the second part of the bracket to give you 6q? 3 times 2q will give you 6q. And now, if you've done it correct, you should know what's going to happen. You should have an identical factor at the top to cancel out with an identical factor at the bottom. And you can see that. P plus 2q, p plus 2q, and they cancel out. So what we are left with is a p take away 2q at the top with a number 3 at the bottom. We don't need to put the bracket round the top, that's it, fine. Okay. Number 7, find the equation of the straight line and give your answer in the form of y equals mx plus c. That wee bit there, they don't normally write that down, okay, but they're giving you a wee hint. Find the equation of the line. So y equals mx plus c, remember the gradient. We need to find the gradient. I'm not going to use the gradient formula because I've got a diagram and c is the y-intercept. Okay, so the gradient. To find the gradient, I am looking for 2 points on the line and I'm going to create a right-angled triangle. I'm going to use that point there and that point there. And I've created a right-angled triangle. Now, to get the gradient, remember, it's the vertical over horizontal. What is the vertical? It is one box. Right, I'm looking at that's my vertical. My vertical is one box, but what does that one box represent? Look at the axis, look at the numbers on that y-axis. They're going up in fives, so that's actually 5 high. Okay, and across the way, this is my horizontal here, so it's 5 over, the horizontal is 2 boxes horizontally, but the 2 boxes, they're going up in 1, so the horizontal is just 2, so that's fine. 5 over 2. You can leave it as 5 over 2, there's not a problem with that. And the y-intercept, we should be able to read it off the y-axis. Where does the line cross the y-axis? There it is, at the number 5. So the equation, y equals mx plus c, put in the right numbers, in the right place, 5 over 2, or 2.5, it doesn't matter which way you write it, plus 5. Okay. Number 8. I hope you're thinking this is quite a straightforward practice paper. It does seem like it. Maybe paper 2, when we move on to that one next time, it will be a bit more challenging because sometimes they balance up like that. Right, okay. Number 8. Part of the graph, y equals cos x, is shown. There's the cos graph, right? Yep, ends at 360. It goes up and down, top and bottom, to 1 and minus 1. Right, cos 60 is equal to a half. Right, okay, so that wee 60 there makes a half here. Right, okay. State 2 values of x. So we're looking on x values along the numbers on the x-axis. State 2 times 2x values for which cos x is negative 0.5. Right, negative 0.5. Let me see if I can try and draw this. Negative 0.5, that's what I'm looking at. Right, negative 0.5. It's about, where does that, about there? Somewhere there. And somewhere there. That's not too bad. Right, I wish I could draw this bigger. Right, okay. From 60 to 90, it's 30. Okay, from 60 to 90, it's 30. Or you could see from 90 down to 60 is 30 back. So in this direction, it's 30 forward. So basically 90 add 30. To be honest, there is no working at all needed for this. So the answer is 120. And in this direction, there's 270, come 30, oops, come 30 back, 270, take away 30, 240. Okay, there is no working at all needed for this. Number 9, multiply out the brackets and then simplify. Okay, I'm going to do this very, very quickly. I think we're all quite good at this. X cubed plus 4x squared minus 1x. Now I'm going to multiply everything in the second bracket by the minus 3. Minus 3x squared minus 12x minus 3 times minus 1. Remember, you're multiplying the amount of people that add them. Minus 3 times minus 1 is a positive 3. Collect any terms together. We've got an x cubed. Let's get the x squareds together. Plus 4x squared is minus 3, so we've only got 1x squared, plus 1x squared. A negative x and a negative 12x, we've got negative 1, take away 12 more, we've got negative 13x altogether. And don't forget your b plus 3 at the end. And that's your answer. Okay. Number 10. A sample of students were asked how many times they'd each visited the cinema in the last 3 months. Oh yeah, like a big fat 0 in the last year. That's one thing we're all missing. Right, okay, from the data we've defined the median, the lower quartile and the upper quartile. To do this, your quartiles, we must put this in order. Oh dear, got all these numbers to put in order. To be honest, see when this has ever come up in a real exam, they would normally not give you as many, maybe 10 numbers maximum. The problem with all those numbers is I'm going to end up stretching it over 2 lines and it's going to be a wee bit more difficult. Right, easiest way I'm going to do to put this in order. 1, 2, I'm counting how many ones I've got. 1, 2, 3, 4, 5. I've got 5 ones. 1, 2, 3, 4, 5 ones. How many 2s? 2, 2, 2, 1, 2, 3, 4. I've got 4 2s. 1, 2, 3, 4 2s. How many 3s? 1, 2, 3, 4. 2, 3, 4. How many 4s? 1, 2, 3, 4, 5. 1, 2, 3, 4. And I've got 2 5s. I would just double check I've counted them all. 2, 4, 6, 8, 10, 12, 14, 16. There's 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I've got 20 numbers, right? Middle of 20 numbers. Come in 10 from each side. Work your way into the middle. If you come in 10 from each side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, can't count. How many did I say there was? 2, 4, 6, 8, 10. There's 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, that's 10 in. I can't count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So I've written some of the numbers a bit more spaced out. That's why that maybe doesn't look like the middle. 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So it's between those two number 3s is the middle. I know it doesn't look like it, but it's because the bigger numbers, the 4s and 5s, I spaced them out a bit more. So the median is in between 3 and 3. Well, it's 3 then, not 3.5. It'd be 3.5 if it's in between 3 and 4. Don't make that mistake. Right, we're going to get our lower quartile. We've got 10 numbers. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Lower quartile, you don't need to write Q1, you can just write what the number is. Halfway between 1 and 2, 1.5. And our Q3, upper quartile, higher quartile, it doesn't matter what you call it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's between 4 and 4, so it's 4. So that's part 1 done. Just double check. Median, lower and upper quartile. That's it done. Construct a box plot. It's been a while since we've been asked to draw a box plot. A box plot is a number line, first of all, that includes the numbers that we have. So from 1 to 5, I'll try and draw this as best as I can. 1, 2, 3, 4, 5. Right, that's pretty good. Now what we do is we mark on the lowest and the highest numbers. 1 and 5. 1 and 5. And now we mark on our 3 statistics that we've just worked out. 1.5, halfway between 1 and 2, that's not bad for 3 and 4. Now these 3 statistics that we've just worked out, we draw this box around them. So that's 1.5, 3 and 4, and the highest and lowest get connected at the end like this. And that's the box plot. Okay, it's probably been a while since you saw one of them. Number 11. 2 functions are given here. Find the values of x for fx equals gx. Oops, that's fx. I don't know what happened there. It's been printed out right. So we have to put them. It says fx equals gx. So basically we have to write the f function, which is that. We have to put it equal to the gx function. Okay, that's what fx equals gx mean. The function of f is equal to the function in g. So we'll put them equal to each other. What we're going to do with that now? It's not a linear equation, it's got an x squared in it. How do you solve a quadratic equation? We can't solve it like that. We have to put all the x's on one side. Oops. Put everything on one side, sorry, not just the x's, everything on one side. To solve a quadratic, it must be equal to 0. So I'm putting everything on the one side. What's going to happen with the 5x and the 3? Minus 5x and minus 3. So there we have our quadratic equal to 0. We need to tidy it up a wee bit, don't leave it like that. Plus 5x, sorry, plus 2x minus 3 is going to be minus 3x. Positive 2 take 5. Minus 1 minus 3 is minus 4. That's much better. And how do we solve this? We solve this by factorising. X times x for your x squareds. 2 numbers that multiply to negative 4 that need to add up to -3. Two numbers that multiply to -4. -4 times +1, or maybe +4 times -1, which is the correct combination that will add up to -3. It's going to be this one. X minus 4, x plus 1. It's not solved though. To get your solutions, you set the factors equal to 0. Set the factors equal to 0. Move your -1 across, -4 across. X is equal to +4, and x on the other side. Move your +1 across. X is equal to -1. That's your two solutions. Okay. Nearly there. I know this is a long one. Express in its simplest form. This is indices. So first rule of indices we're going to do here is we're going to tidy this wee bit up here. What happens when you do y cubed to the power -2? What happens with the indices? You multiply them. Y to the power -6, because 3 times -2 is -6. And now the other rule of indices, when you do this multiplication like this, you don't multiply the indices, you add them. 8 take away 6, or 8 add -6 is y to the power 2. That's it finished. Well, that's that question finished. I think this might be the last one. Here is a parabola. What is the coordinates of the turning point? The coordinates of the turning point come from the equation. They come from here. Okay? Simply, remember x minus 1 in the bracket means x is +1. And the -16 at the end is your y value of your turning point. That is all it is. Okay, part B, what's the equation of the axis of symmetry? The axis of symmetry is an equation that begins with x equals. The axis of symmetry comes all the way down here, right through the turning point, right through your x value on the turning point. And remember, we've just worked out x is 1. That's your equation of the line of symmetry. This is the last one. Simplify the thirds. So, root 45, I'll do that first. Two numbers that multiply to 45, and one is a square number. Think of your square numbers. If you don't know your square numbers, write them down. Not 2. 2 2s are 4. 3 3s are 9. 4 4s are 16. 5 5s, these are all your square numbers I'm writing down the side. What's the highest one that goes into 45? 9. So it's root 9 times what makes root 45? 5 9s are 45. So root 45 is actually root 9. Remember, we've put that first purely because we know the square root of 9 is 3. So root 45 is actually 3 root 5. So to answer the question, root 45 take away 2 root 5. Well, the root 45 is 3 root 5, take 2 root 5, and if you've got 3 root 5s and you take away 2 root 5s from it, you are left with just the 1 root 5. You don't need the number 1 at the front, you can just leave it as root 5. Okay, try the questions that I've supplied for you. They are very similar to these ones. Okay, and we'll hopefully see you very soon. Bye.